Part 2, total current 2.7 amps divided into thirds. A third drops off to each pathway, and then they recollect, right? So we got 0.9 amps coming down, joining with another 0.9 from the middle, making 1.8 in that middle section. And then that 1.8 is going to gain another 0.9 from the last pathway. So 1.8 plus 0.9 gives you your total again of 2.7. All right. And then here, watch. So I'll leave it here at the total. This is with 3 pathways. 3 times 0.9 is 2.7. Well, if I disconnect this one, it's going to leave us now with back to 2 pathways. So, what would you expect the total current to do? Just drops down. It's like that third line of people moving tennis balls. They quit on you and they leave you. So you're back to doing only like twice as good rather than 3 times as good. So we have 0.9 and 0.9 still moving the same, doing the same job, but now they total only 1.8. Break in different parts of a circuit. I guess that's the last part. When you do it in a parallel circuit, that's the benefit of a parallel, is you can operate different portions of it independently, cut off different parts, and the others still perform the same. Not only do they keep on running, but they keep on running at the same current. Fortunately, your houses, for the most part, are wired in parallel, because otherwise, if you wanted to go to bed and you turn off your light, it'd shut off everything in the whole house. And so apparently everybody have to go to bed. Likewise, if you plug in too many things, you notice as you keep on plugging in stuff, we keep on adding pathways, the current, total current goes up and up and up and up. So if we keep on adding things, this is like if you keep on plugging in too many things in your bathroom, or you turn on one too many things in the kitchen, eventually your total current, your mainline current, gets higher and higher and faster, and it'll get to the point where it's too fast and it'll overheat and catch your house on fire, And so to keep that from happening, that's why we have those things called circuit breakers and fuses, because they will detect that the current, you're asking for too much and the current's getting too high, and it'll blow up the circuit. So it'll shut everything down. It's like a switch that's attached to the main line. So I'll show you, like, I plug in something else. Now we're up to 3.6 and this is faster. And we can get to the point where it's too fast and it'll catch us on fire. So what the breaker will do is it'll open up in the main line and it shuts everything down, because the total current flows through that main line. It'd be like shutting down the highway. If you shut down the highway, no one can get to the individual towns. But on the other hand, if you shut down only one of the individual towns, cars can still get to the other towns and get through them and travel along the highway. In a series circuit, whenever it's just one loop, this is like there's only one way to go through town or something. So if you shut down that only road, no one can go anywhere. No one can leave. No one can come in. All right, because there's only one pathway. So if I take a series circuit and I break that, it shuts down everything. Well, whatever is there, okay? Because there's only one pathway. There's no other way for the electrons to flow around. That's pretty much it, I think.